In 2015, about 10 years ago in a certain program, when SpaceX was still in its infancy, Elon Musk had already started planning for human colonization of Mars. When the host asked, "How can Mars be transformed into a planet suitable for human habitation?" Musk gave a shocking answer. "How would you do that? You'd warm it up from the sun. There's the fast way and the slow way. Give me the fast way. The fast way is to drop nuclear weapons over the poles. You're a supervillain." As we know, the average temperature on Mars is 60 C. This temperature is entirely unsuitable for human habitation. If traditional methods are used to terraform Mars and make it warmer, it would take at least 1,000 years. So, is the idea of dropping nuclear bombs on Mars poles feasible? Mars poles contain large ice caps. Could nuclear weapons melt this ice and create oceans on Mars? Today, we'll discuss Musk's Mars plans and whether, in our lifetime, we could witness humans colonizing Mars. Elon Musk is not the first to propose plans for colonizing Mars. As early as 2011, a Dutch company announced that they had received funding from investors and would use this funding to send the first humans to Mars and establish a permanent colony there. This project was named Mars 1. The unique aspect of this plan was that anyone in the world could apply. The registration fee was also low, only $35. But the cost was that this was a one-way ticket. Given the challenges and costs of traveling to Mars, they would only send applicants to Mars without guaranteeing their safe arrival. As for a return trip, that was out of the question. Clearly, the first batch of Mars volunteers would be experiments. These individuals were highly likely to die on Mars. Even so, the project has still garnered significant attention. Volunteers from all over the world have eagerly signed up. A total of 200,000 people from over 100 countries have signed up for Mars 1. The plan will eventually go through a series of selections. From the large pool of applicants, 2 men and 2 women will be chosen. These 4 will undergo 7 years of training. Then they will be sent to Mars. They will become the first residents of Mars. They will establish humanity's first colony on Mars. The Mars colony will consist of 6 interconnected modules, along with 2 cylindrical plant growth modules. There will also be 2 rovers. These will be the entire belongings of the 4 Mars volunteers. They will also receive supplies from Earth. This is a very expensive, difficult, and extremely risky project. The timeline for the entire plan is as follows. In 2013, Mars 1 will select the second round of volunteers, about 2,700 people. By 2014, the list will be reduced to 700 people. By 2015, it will be cut down to 100 people. This group will be known as Mars 100. It will consist of 50 men and 50 women. They will enter the next round. Of them, 40 candidates will pass the interviews. In 2016, the final 4 will be selected. After 7 years of training, they will be launched to Mars in 2023. In 2013, Mars 1 signed a contract with Lockheed Martin for the Mars lander mission. It will then be followed by the launch of a Mars orbiter communication satellite developed by a UK company, used for communication with Earth. Meanwhile, a rover will also be sent to Mars to explore the landing site. Then, various modules will be launched to Mars, waiting for the volunteers to arrive and assemble them. Everything seems reasonable. But due to the complexity of the plan, especially with the huge financial challenges, Mars 1 CEO, Bas Lansdorp, predicts. However, due to the complexity of the plan, especially the huge financial challenges, Mars 1 CEO, Bas Lansdorp, predicted that the cost of the first mission would reach $6 billion. As a result, the launch date for Mars 1 was repeatedly delayed from 2023 to 2027, and finally set for 2031. During this period, Mars 1's venture capital company was established to attract investors from around the world interested in the project to address the funding issue. But this project, which offered almost no return on investment, was hard to attract investors. This was the main reason the plan eventually went bankrupt. Lockheed Martin later confirmed that the $200 million contract signed initially had never been received, causing delays in the development of the lander. The UK's Surrey Satellite Technology Company also stated that they had not received payment for the satellite contract. Mars 1 faced criticism from scientists, engineers, and aerospace industry professionals. This project was referred to as a suicidal mission in the academic community. In 2014, a 5-person team from MIT released a 35-page report detailing their analysis of Mars 1, pointing out various issues. The final conclusion was that the plan lacked the essential technology for landing on Mars. From an economic and technological standpoint, it seemed there was no chance of success. Even if these Mars volunteers reached Mars, they could survive for at most 68 days. This report had a major impact on Mars One's project. The company's financing progress stalled. And in 2019, the plan was declared bankrupt. Mars One was over. Some believe this was a space version of a Ponzi scheme. Since the Dutch company had received millions of dollars in registration fees during its brief existence, the project completed only 2 conceptual designs. A large amount of funds were used for speeches and publicity. Many don't even believe we can build a Mars base. In the end, Mars One truly turned out to be a scam. It preyed on humanity's enthusiasm for outer space and the dream of reaching Mars. Despite receiving massive attention, but it failed to raise enough funds at any stage of the mission. Perhaps the biggest legacy of the plan was sparking public enthusiasm for Mars immigration. Some believe that over time, private companies may actually achieve the feat of human migration to other planets. Interestingly, a key part of the Mars One project was to use a private company's rocket to send 4 volunteers to Mars. That company was Elon Musk's SpaceX. Mars One originally planned to send the crew to Mars in 2031, using SpaceX's Falcon Heavy rocket. Of course, SpaceX never received any payment after signing the contract. Although Mars One failed, it is unclear whether Musk was influenced by the project and decided to continue sending humans to Mars, thus developing new launch systems and a series of technologies for Mars immigration. With Mars One's failure as a lesson, people began to become skeptical of Mars immigration plans. So when Musk first proposed in 2015, sending humans to Mars, he faced mostly skepticism and mockery, but with the success of SpaceX's series of space launches and SpaceX becoming a key partner for NASA and the Russian Space Agency, people finally realized Musk was serious. Despite Musk's ambitious claims to send the first humans to Mars within his lifetime, most scientists actually don't believe that humans can settle on Mars in the short term. Humans will likely send astronauts to Mars by 2050. For short stays before returning to Earth, living on Mars long term is simply too difficult. This is because Mars' environment is extremely harsh, even harsher than Earth's most extreme conditions. Humans will likely send astronauts to Mars by 2050 for short stays before returning to Earth. Living on Mars long term is simply too difficult. This is because Mars' environment is so harsh. It's even more brutal than Earth's most extreme conditions. First, the average temperature on Mars is 60 C, with surface temperatures ranging between 80 C to 20 C. The poles can drop to 139 C. In summer, the highest temperature near the equator is only 20 C. These extreme temperatures are caused by Mars' thin atmosphere and lack of a greenhouse effect. Therefore, when operating on the surface of Mars, astronauts need to wear specially designed spacesuits. In addition, Mars' atmosphere is only 1% as thick as Earth's. The air pressure is only 0.6% that of Earth's. Mars also has an extremely weak magnetic field, just 0.5% of Earth's. This allows a lot of solar radiation and cosmic rays to hit the surface directly. Unlike Earth's magnetic field, Mars' weak field cannot protect the surface from these rays, so activities on Mars' surface are almost like being exposed directly to space. Furthermore, Mars experiences intense dust storms, which can be either local or global. Global dust storms can last for months, with winds reaching up to 200 miles per hour. These are far stronger than the largest typhoons on Earth. They greatly reduce visibility on the surface of Mars and can severely affect Mars rovers and solar panels. Imagine not seeing the sun for months while enduring harsh winds and sandblasts. What would that feel like? Therefore, Musk's claim of Mars immigration by 2050 is simply based on landing a rocket on Mars and building a fully enclosed base. This is still far from true. Mars immigration. In fact, the scientific community doesn't even believe we can build a Mars base. Most scientists believe that human migration to Mars will only happen in the 22nd century. This is because humanity doesn't even have experience building large-scale colonies at the Earth's poles, skipping Earth's harshest environments. To colonize Mars' even harsher environment is simply impossible. Most scientists think human migration to Mars is a 22nd century goal. This is because humanity doesn't even have experience building large-scale colonies at the Earth's poles, to skip Earth's harsh environments and go straight to colonizing Mars with an even harsher environment seems even more impossible. Of course, Musk has definitely considered these problems. His goal is to establish a foothold for human migration to Mars and to be the first person to drive Mars colonization. As long as he successfully sends the first group of humans to Mars, he will have achieved his goal. Looking at it this way, Musk's Mars plan is essentially a repeat of the failed Mars One mission, but appears more feasible. According to the crewed mission plans by SpaceX and NASA, before the first human mission to Mars, they will first send a probe to Mars to select potential landing sites and base locations. Considering Mars' harsh environment, the landing sites will likely be in Martian underground caves. Once this is settled, Musk's newly constructed cargo spacecraft will deliver scientific equipment and probes to Mars. After multiple launches, Various materials for Mars bases will also be sent. Only after that will the crewed missions launch. Musk said that fundamentally, he is building a 55 million kilometers cargo route from Earth to Mars. This is a regular route, with dozens of cargo ships, launching every 26 months, delivering people and goods to Mars. It will be as punctual as an airplane. If scientists worldwide find this route to be reliable and more cost-effective compared to past methods, they will formulate plans for greater investment. Why is Musk so confident? And compared to past methods, the cost is significantly lower. They will formulate corresponding plans and make greater investments. Why can Musk boast so boldly? It's because SpaceX's new system is the world's largest rocket transportation system. The Saturn V rocket, which sent humans to the moon last century, had a thrust of 3,400 tons. In comparison, the newly built system has a thrust of 7,500 tons. The Saturn V rocket's low Earth orbit payload capacity was 118 tons, while the newly built system's payload capacity is 150 tons. This is only the V1 version of the new system. The V2 version will improve on the V1 with a longer body and more engines. Its payload capacity could increase to 200 tons. The crewed version, the V300, will become the world's first rocket with a launch thrust over 10,000 tons. Its payload capacity will reach 300 tons. Another feature is that the new system uses full recycling technology, which is the biggest difference from traditional rocket technology. This means the cost of rockets is controllable, and it allows for multiple starships to be launched at once. Imagine 10 starships being launched to Mars at the same time. Each starship has a payload capacity 10 to 100 times greater than traditional rockets. Then, the rockets automatically return to Earth, like commercial airplanes, continuously operating between Earth and Mars. From the perspective of traditional rocket launch methods, this seems unimaginable. Currently, there are 180 rocket launches worldwide. But Musk predicts that after the new system is fully mature, the launch frequency will be 5 times higher than the global total. That's 900 launches per year. Musk has repeatedly explained that he's not launching a single spacecraft, but a fleet. Once everything is ready, the new system will be launched by Super Heavy rockets to Earth's low Earth orbit. Then the rocket booster and starship will separate, and the booster will automatically return to Earth. It will re-enter the atmosphere and land at the launch site. This method is meant to reduce launch costs and improve operational efficiency, preparing for the next launch. Once the fuel is replenished, the launcher can connect with the starship and be launched again. The starship that is launched into space will fly for a period of time and dock with the previously launched fuel starship. After refueling, it will use its independent thrusters to head directly toward Mars. After 6 months of flight, it will reach Mars and land at the designated site. When the interplanetary settlers arrive, they will see Mars base modules that were launched in advance. Musk has said that he wants to send 1 million people to Mars. But this will definitely not be achievable in our lifetime. It won't be. The first batch of settlers to Mars is expected to number between 50 to 100 people. They will build a small permanent Mars base in preparation for future settlers and the construction of Mars cities. These 100 people will face extremely harsh conditions, such as low temperatures, radiation, low gravity, and dust storms. Cosmic radiation will also be a threat. They might not survive long on Mars, but they will provide valuable experience for survival on Mars. After the first batch of settlers arrives, they will assemble the Mars base. Each module will be modular. Because of the uncertainty of Martian dust storms, solar panels will only be auxiliary power. The base will rely on nuclear power for electricity. Of course, Musk's plan is to build a massive solar panel around the Mars base, using Tesla technology to collect power. As for nuclear power, it will rely on NASA's small modular Q reactors. This is a device that will be launched in advance. NASA plans to test this nuclear device on the moon's surface in the coming years. As for living conditions, the most critical issue is food. On Earth, resources like oxygen and water are easily available. But on Mars, they will have to be artificially generated. At the same time, because the Martian soil contains toxic substances like filtered acid and salts, it's unrealistic to grow vegetables on Mars. The Martian soil needs to be improved by adding organic matter and fertilizers to adjust the soil pH, or using hydroponics and advanced farming techniques like soil mixing and gel irrigation. These techniques will help humans achieve small-scale food self-sufficiency. Additionally, the communication delay between Mars and Earth ranges from 3 minutes to 22 minutes. However, dangerous moments often last only a few seconds, with a response time of only a few seconds. So, any emergency on Mars will not have Earth-based rescue support. The settlers will have to rely on themselves. Therefore, when humans reach Mars, everything must start from scratch, with no room for error. Any failure could lead to the first batch of Mars settlers being wiped out on Mars. If everything goes well, and the Mars settlers survive their first Martian year with enough of the group still alive, the Mars base will be able to expand after receiving new supplies. After 50 to 100 years of construction, the Mars city may begin to take shape. After 50 to 100 years of development, the Mars city could begin to have scale. By then, new supplies brought in will mainly be equipment. The settlers will use this equipment to build the city. For example, 3D printed buildings, a technology that has already been tested. Only by using Martian resources can humans survive on Mars. After 100 to 200 years of development, Mars can enter the second phase, which is the Mars terraforming program. In order for Mars settlers to transition from a self-sufficient settlement to reaching the critical point of Earth-like conditions on Mars, the first step is to make Mars warmer. This will trigger the greenhouse effect. Due to the early similarities between Mars and Earth, terraforming Mars will be humanity's only way to achieve interstellar migration. Mars had a thick carbon dioxide atmosphere on its surface 3 billion years ago. But for unknown reasons, Mars' core cooled and its magnetic field disappeared, causing the atmosphere to be blown away by solar winds. Most of the carbon dioxide was absorbed by the soil and froze. The first step in terraforming Mars is to warm it up, to create a warmer climate. This will release the carbon dioxide from the soil. It's expected that the carbon dioxide released from the soil will form a new atmosphere, raising the temperature of Mars by 5-6 C. At that point, some ice will start melting into water, which will evaporate and create weather phenomena like rain and snow. The greenhouse effect will re-emerge. Once the temperature near Mars' equator remains above 0 degrees year-round, Mars will have a stable supply of liquid water. By 2250, Mars will be able to grow plants. Initially, the focus will be on cultivating fungi and mosses that promote photosynthesis, and later, the cultivation of superplants that can release more oxygen. These plants will eventually release enough breathable air for humans. This process will take over 1,000 years. Of course, there are faster methods. There are large amounts of water ice at Mars poles, which is already confirmed. By melting this ice, we can cause huge changes in the Martian environment. The first plan is to build a giant mirror. The mirror would have a diameter of over 120 kilometers and would orbit at an altitude of 21 kilometers above Mars' surface. This mirror would reflect sunlight onto specific areas of Mars to release the frozen atmosphere and water beneath the surface. However, before such a large-scale mirror can be built, there is the challenge of material breakthroughs. The second plan involves using asteroids. A 5-kilometer diameter asteroid could be directed to collide with Mars. The enormous energy produced by the impact. A 5-kilometer diameter asteroid could be directed to collide with Mars. The enormous energy generated by the impact would melt 1 trillion tons of ice on Mars, turning it into water. The ammonia produced by the asteroid impact would also help warm Mars significantly. It's estimated that 100 such impacts could trigger a greenhouse effect on Mars. However, the scientific difficulty of implementing this plan is also enormous. The third plan is the one Musk mentioned in an interview, which involves dropping nuclear bombs on Mars poles to melt the ice caps. This idea is known as nuclear explosion softening. According to estimates, at least 10,000 nuclear bombs would need to be dropped to melt all the ice. The challenge is how to transport these bombs, and the pollution caused by the bombs, which is a huge issue. Therefore, this plan is the least feasible. So it seems that terraforming Mars will still require a long process. Looking ahead to the 22nd century, perhaps traveling to Mars will be a new option. When our descendants see the magnificent rocket cities under construction, who knows how they will feel? How many of them will stay on Mars forever? Becoming part of Mars settlers? As for Musk's Mars colonization plan, many people do not agree with it. That's because we've always had a misconception. That is, when doing something, especially something difficult, we always think we need to be fully prepared. But the result is often that nothing starts, because there is never a perfect time to be ready. In space exploration, Musk and his SpaceX company use the available rocket technology of today, even improving on previous Soviet technologies, to achieve their goals as best as they can. They don't wait for perfect technology to emerge, but instead, focus on making the best use of what they have. That's what's surprising about Musk. He is definitely one of the people pushing humanity forward. A good example is when Musk acquired Tesla in 2008. This is what makes Musk so surprising. He is undoubtedly one of the people pushing humanity forward. A great example of this is when Musk acquired Tesla in 2008. At that time, Tesla was a near bankrupt electric car company. No one believed that electric vehicle technology was ready. Building all electric cars was laughed at back then. If it weren't for Musk's belief and drive, perhaps electric vehicles would still be limited to a small-scale market today. But the result is that Musk almost single-handedly accelerated the development of electric vehicle technology worldwide. In space technology, Musk is doing the same thing. So, his success is no surprise. Although Musk's Mars colonization timeline has been delayed multiple times, the new test launches keep failing. But they continue to cycle until success. The Mars colonization plan is accelerating. Although Musk's previous statements have had several setbacks, the constant upgrades and improvements are obvious for all to see. The relentless efforts of the development team have indeed made this vision seem no longer out of reach. In the future, on Mars, there will certainly be a monument to Musk, honoring this promoter of interplanetary migration. Just as trees scatter their seeds through fruit, humanity also needs to sow its civilization to distant, uncharted places.